This is the second half of section 8.2. The first example we're going to be doing, we asked to write each number in standard notation. One of the biggest things to remember, what is standard notation? Standard notation is just normal numbers. I know that sounds kind of unique, but a normal number, that's like 562, or it's 4003. No decimals, could be decimals, but definitely no exponents. So that standard notation is just normal numbers. So, let's look at our first one. And let's actually change this first one because I don't want to do something to the 12th. So let's do something a little bit smaller and more manageable. Let's do to the 5th. So we have 3.2 times 10 to the 5th. Well, let's write down 3.2. And now we need to move our decimal place 5 positions to make this number larger, since that's a positive exponent. So 1, 2, 3, 4, 5. I'll make little swoops there, and I'm going to fill those swoops in with zeros. Now I'm going to rewrite my number without my decimal, as if it was just a normal number, and put in our commas. So what is this number? 320,000. Our second one is 5.07 times 10 to the 4th. Well, let's write our 5.07 as it is listed above, and then let's determine we need to move our decimal place by 4 positions to the right. Because it's a positive exponent, we need our number to get larger. So 1, 2, 3, 4. Once again, we're going to fill in our little swoops with zeros, and then below we'll write our number without a decimal, just as it's listed above. Putting in the commas, what is our number? In standard notation, 50,700. Moving down to example C, the difference on this problem is we have a negative exponent. So as we look at this problem, we're going to write down our number, 5.6. Now you'll notice I wrote that a little bit more in the middle. The reason is this is a small number, and we're going to have to move our decimal place not to the right, but to the left, because it's a negative exponent. So 1, 2, 3, 4 to the left. We're going to fill those in with zeros, and we're going to put our decimal point at the front. So as a decimal, this would be 0.00056. It's a very, very, very small number. Our last one in this section, we have 8.3. Well, by now you've probably picked up the fact from the previous problem that a negative exponent, we need to write our original number a little bit to the right because we're going to be moving the decimal place in the other direction. How many places will we move the decimal place in this case? We'll move it 2 spots. So 1, 2. Let's fill in the missing swoop with a 0, put our decimal point at the front, and we have 0.083 as our answer. So in summary, standard notation means you have normal numbers. Positive exponents, you move your decimal to the right. Negative exponents, you move your decimal to the left. Our bottom section talks about ordering our decimals in order from largest to smallest. To do this, we have to compare our numbers and write them all in decimal form. So let's do this with our first number. Notice they all have negative exponents, so I'm going to write my number to the left. There's my decimal point originally, and so let's move it over. 7 places. 1, 2, 3, 4, 5, 6, 7. That's a lot of zeros, so let's fill these in. 0, 0, 0, 0, 0, 0. Alright, now we do our next one. We have an 8, and we're moving it over 8 places. Starting here, 1, 2, 3, 4, 5, 6, 7, 8. Filling all those in. These are some very small numbers as we compare. This is just good practice as we talk about this. Our next number is a 7, and we have to move that decimal over 6 positions. 1, 2, 3, 4, 5, 6. This does start to get a little bit tedious, as you can imagine, as you're starting to try to figure out all these decimals at once. Our last one has 10 decimal places. So we start with a 10, with a 6, and we're going to move that over 10 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's fill all those in with zeros. Now, to compare decimals appropriately, they have to have the same number of decimals. Well, this one had 10, so let's write them all with 10 since that's the most. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 7, 8, 9, 8, 9, 10. Excuse me, let's check this one. 1, 2, 3, 4, 5, 6, 2, 4, 6, 8, 10, 2, 4, 6, 8, 9, 10. So now we compare our back numbers. We have 6, 70,000, 800, and 9,000. The largest number is our largest problem. So that's our largest. You'll also notice it has the smallest exponent. Our next largest number is 9,000, so that's the second largest. Our third is the number with 800, that's our third largest, and our last is the number with just a 6. That's our smallest. You may have picked up that the shortcut here is to figure out how do we figure this out quickly. Well, the largest exponent that's with a negative power will be the smallest, and the largest exponent with the smallest negative number is the largest. Let's look at our bottom one, a little bit more normal numbers. -3. Let's take 50.1 and let's move that 3 decimal places to the left. 1, 2, 3. So that's 0.0501. Let's take 4.8 and that's going to move 1 decimal to the left. That becomes 0.48. These are much more manageable. 0.52. We're going to move that 3 decimal places. 1, 2, 3. Put our zeros in. 0.00052. Our last one is 56. Move that 2 decimal places. That becomes 0.56. We compare decimals. This third one has 5 positions, so let's write them all with 5 positions. Now we compare. What's the largest? That's this last one, 56,000. So that's the first number, that's the largest. What's our second largest? 48,000. Our third largest, 5,010. And our smallest is 52. So here's a more realistic manner, but the point being we need to write each of our decimals with the same number of positions in order to quickly compare them. Because the decimals are not all normal in terms of scientific notation, it provides a little bit more of a challenge. Lastly, at the bottom, we're multiplying a number in scientific notation. This is a very simple process so long as you remember just to multiply it times the first number. 8 times 7 is 56. Do not do anything to the negative exponent. Now, our problem is this is not scientific notation, so we have to write this as 5.6 times 10 to a power. Our rule of thumb is since the number gets smaller, the exponent gets bigger, and bigger than -3 is -2. Our second example here, 0.2 times 3 is 0.6 times 10 squared. Once again, don't do anything to the 10 squared. 0.6 is not scientific notation, so we write that as 6 times 10 to a power. Here the number gets larger, so the exponent gets smaller. Someone asked in one of our classes, what happens if you were to have 0.003 times 10 to the 5th? How many positions does it move? Well, you have to go 3 positions to get 3. So if the number gets larger, then the exponent gets smaller by 3 positions. So that's 3 times 10 squared. This concludes our lesson for section 8.2.